Okay, welcome back to math class and welcome to chapter 9. Chapter 9 we're going to be talking about quadratic functions. So today we're just going to learn kind of what that is and what it looks like. Up until this point we've been dealing with linear functions, functions that make a line. This is going to be our first function we're learning about that is a non-linear function. Now it still is a function, so it still must pass our vertical line test on our graph. But it is not linear. Instead, they're what we call parabolic functions. In other words, they form, quadratic functions form a parabola. And a parabola looks like this. It either curves down like this or like this. Now the formula, or the form, the standard form of a quadratic function is going to look like this. A times x squared plus bx plus c. Hopefully that looks familiar because we learned how to factor those kinds of equations in the last chapter. But for right now, what we're talking about, this is a quadratic function. It's going to be in this form. Now, if a, in this equation, the leading coefficient of the equation is greater than 1, here I'm going to write it over here, a is greater than 1. In other words, if a is a positive number, our parabola is going to look like this, going up forever, hitting a minimum, and then going up forever on both sides. If our a is less than 1, in other words, if a is negative, then our parabola is going to have a maximum and then be going down in both directions forever. Now both of these dots that I labeled minimum and maximum, they're called the vertex of the parabola. So no matter what direction the parabola is going, if I asked you for the vertex, you would find the point where the parabola changes directions, and that's our vertex. How you tell if it's a minimum or a maximum is just, is it at the bottom? Is it the minimum value, the lowest value of our parabola? Or is it the maximum, the highest value of our parabola? And when you have when a is less than 1, it will always be a maximum that you're looking for. When a is greater than 1, it'll always be a minimum that you're looking for. One other thing about parabolas that's important for us to know is that they have, going through their minimum, something called, oh gosh, I missed that. Something called an axis of symmetry. Here's that on that one. Coming down here. Axis of symmetry. Now, what this means is this is the line that we can draw through the middle of our graph, that if I folded the graph over on itself, it would match. So it's the middle point of our graph. This is going to go straight through our vertex, because our vertex is where our graph changes directions. So it's also the very middle of our graph. Okay, so now we're going to practice graphing one, and then we'll figure out how to find these points on our graph. So let me erase this. Like I said, every quadratic, in order for it to make a parabola, it has to be in the quadratic form, which means it's going to look like ax squared plus bx plus c. So if your equation doesn't look like that, then you know it's not going to make a parabola with our x squared. That's what's important there. Okay, so if I said y equals 2x squared plus 4x minus 6. There's our equation. And I said, please graph this equation for me. The first way we're going to learn to graph these equations is by making a table of values and then plotting those points. It's like how we first learned how to graph. So here my x column, my y column. There's my table, and I'm going to go ahead and draw my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2. We'll see if we need more points than that as we go. Now when we look at this, we know that we have our x-axis going this way, x-axis, and we have our y-axis going up and down. Oh. Axis. Okay, so to graph this with a table, what I'm going to do is I'm going to choose x values, and I'm going to plug them into this equation so that I get my y value. The first one I'm going to do is I'm going to just start with number 1. So that's going to make our math a little bit easier, because if I did 1 squared, that's 1, and 2 times 1 is 2, plus 4 times 1, which is 4, minus 6. 2 plus 4 is 6, minus 6 is 0. So at 1, when our x is 1, our y is 0. So that's going to be our first point on our graph. When x is 1, y is 0. Okay, so let's just go down the line. Let's try 0, because that's also going to make our math pretty easy, because it'll be when x is 0, this will be 0. When x is 0, that'll be 0, minus 6. So when x is 0, our y is going to be negative 6. So when x is 0, 1, 2, 3, 4, 5. Oops, gotta make my graph a little longer. 6. Let's go ahead and add a few more. Okay, so it looks like we're already going down. Now what I know about this, just pause for a second. Our a value is positive. So I know in my head that eventually my graph is going to be shaped like this. Right? So what I'm looking for in my y values is for them to decrease until they hit a minimum point and then start increasing again. Right? So that's how we can kind of tell which x's that we should try, is we need to take our x value down until it starts coming back the other way. Okay, so I tried 1 and I tried 0. Let's try negative 1. All right, so if I plug negative 1 in here, negative 1 squared be negative 1 times negative 1. 2 negatives make it positive. So that's going to be 1. 2 times 1 is 2. Negative 1 times 4 is actually going to be, make it minus 4, and then minus 6. So 2 minus 4 minus 6 is going to give me minus 8. All right, so at negative 1, my graph will be at minus 8. Okay, so we're still going down. So remember, we're in our head thinking, I need to figure out the place where our graph turns upwards. So I'm going to keep going down, minus 2. Okay, so if my x is negative 2, I'm going to have negative 2 squared. Negative 2 times negative 2 is going to be positive 4. 2 times 4 is 8. 4 times 2 is, negative 2, right? Negative 2. 4 times negative 2 is negative 8. Minus 6. 8 minus 8 is going to give us 0. So 0 minus 6 is minus 6. Okay, so now here I have minus 6 and minus 6. So when I'm at negative 2, looks like my graph is starting to come back up. So if I did this right, when I do -3, I should be back up at 0. Let's give it a shot. -3. Okay. So if I put -3 in, -3 times -3 is going to give us 9. And 9 times 2 is 18. 4 times -3 is going to give me -12 and minus 6. All right, 18 minus 12 is 6. 6 minus 6 is 0. So yes, when I hit -3, I'm going to be all the way over at 0. So now that our points kind of go in that shape, we know we did our math right, and we can draw our parabola. Now the other thing that we can do with this is, I know where my minimum is, because it's the lowest point on the graph, and it was where? It was -1, comma, -8. So that's my minimum. It's the lowest point in my graph, -1, -8. Something else you'll have to find is your axis of symmetry. Remember, I told you that is the line that we can draw through our graph to cut it in half. And it's also going to go through our minimum. So our axis of symmetry will be the line where x equals -1. So it's, I guess my graph was a little off, but it should be this line right here, where we can fold our graph in half. And that's always going to be our x value of our minimum. So that should be pretty easy to keep track of. So that's our minimum, that's our axis of symmetry. One other thing you might be asked to find is the y-intercept. Now you guys are already really good at finding the y-intercepts of graphs. We know that the y-intercept is the place where x equals, it's just one y-intercept, the place where x equals 0. So we could look on our graph, the place where our graph crosses the y-axis, which is -6, and we can verify that. We can verify that in our table as the place where x equals 0, y is -6. So our y-intercept is 0, -6. And those are the three things that you'll need to be able to find on your graph. The lowest point, -1, -8, the axis of symmetry, and the intercept. Good.